Hey guys, welcome to the another topic of discussion today, that is shunt equation. Today we are going to derive the shunt equation, the equation is have been derived from the original point. Okay, so what is shunt equation? First, shunt equation is nothing but it quantifies how much the extent of the venous blood which is passing through the pulmonary capillaries is not oxygenated, that is they are contributing to the dead space, that is alveolar dead space. It is quantified with the help of the shunt equation. Okay, so for that first we have to know the blood flow through the venous, that is pulmonary veins. Qt is the total blood flow through the pulmonary veins, and the venous content of the oxygen content of the venous blood is CV O2 we will write. Okay, when this blood passes through the pulmonary capillaries, if they involved in oxygenation, that is involved in the gas exchange, it can resulted in the Qt minus Qs. So nothing but total flow which is occurred and which is not involved in the shunt, that is Qs. Qs is nothing but the fraction that is involved in the shunt. So Qt minus Qs is the nothing but the alveoli, pulmonary capillaries nearing the alveoli involved in the gas exchange and contributing to the oxygenation. It can be written as Qt minus Qs. Whereas the blood which is passes through this is non-shunted fraction. Okay, when the blood passes through these capillaries and doesn't involved in the oxygenation, doesn't involve the gas exchange, that is the shunted fraction. So shunted fraction can be written as Qs. Okay, Qs means now you understood total flow Qt minus Qs through the shunted flow can be written as Qt minus Qs. Okay, so the end capillary oxygenation can be written as C dash O2. C dash is nothing but your capillaries. Okay, so next the total after getting oxygenated, the blood passes through the arteries. So there it can be written as CaO2 is the oxygen content of the arterial blood, and the flow through which occurring through this is Qt. Okay, this is the arterial end. This is the arterial end. Qt is the total flow which occurred through the pulmonary veins and through the pulmonary capillaries, finally entering the arteries. And CaO2 is the oxygen content of the arterial blood, and remaining Qt minus Qs is through the non-shunted fraction. Qs is through the shunted fraction. Now you with the help of this we will derive the equation. First, the total flow Qt into CaO2, that is through the end side, end product of what we are getting after oxygenation, is equal to what other than the blood flow passes through the shunted equation as well as through the non-shunted equation. How it can be written? Qs, when it is shunted equation, it is Qs means the total blood which is not involved oxygenation. So the oxygen content of the blood is same as that of venous blood. So CvO2 here. So Qs into CvO2 plus the blood flow through the non-shunted fraction, that is Qt minus Qs into the end capillary oxygenation C dash O2. So when you derive this equation, that is Qt CaO2 is equal to Qs CvO2 plus Qt C dash O2 minus Qs C dash O2. So just make the that shunted fraction to the one side and the non-shunted fraction to the other side. Okay, so just making that Qs negative symbol, when I taken to the positive side, it will become Qs C dash O2 minus Qs CvO2. This Qs CvO2 it will come, and remaining here what will this side is left, that is Qt end capillary oxygenation minus Qt CaO2. Okay, so just take the Qs as a common. Qs, both of them having Qs as a common. So the C dash O2 minus CvO2, which is equal to Qt is a common. So that Qt just taken C dash O2 minus CaO2. So Qs by Qt, that is shunted fraction Qs by Qt is equal to C dash O2 minus CaO2 divided by C dash O2 minus CvO2. So this is the shunt equation, final shunt equation, where CaO2 we will derive from arterial oxygenation, we can get from the ABG, end capillary C dash O2 can be derived from the alveolar gas equation, we will be deriving the end capillary oxygenation, alveolar gas equation. Okay, next CVO2 can be measured with the help of the CVP. Okay, so the normal value of the shunt fraction will be approximately, normal typical healthy lung will be approximately 4 to 5%. Okay, this is the complicated equation. How this equation is derived is simply, I have made it more simplified version. If you have any doubt regarding this, you can simplify, you can ask me anytime, you can comment me down so that I will reply to your messages. Okay, so that just you just put the total flow outside through the arterial, then that is QT into CaO2 is equal to QS into CvO2, which is blood flow through the shunted fraction. QT minus QS CC-O2 is equal to the non-shunted fraction. So QT CaO2, QS CvO2 plus QT CC-O2 minus QS CC-O2. So take the shunted side one side, QS CC-O2 minus QS CvO2 is equal to QT. So QS as a common, so QS by QT is equal to, you will be getting the final shunt equation. If you have any doubt regarding this, you can communicate me. Thank you once again for your support, guys. If you are new to my channel, please subscribe my channel. And if you like my video, just push the thumbs up button so that it will motivate me for doing more videos for you guys. Thank you, guys.